Rust sucks. Right? Rust sucks. If I didn't know better. Okay? But because we know better in today's event, in the first grassroots conference for Rust in the Philippines, I want to onboard you on the knowledge of why Rust doesn't suck and why Rust is something you can leverage in the future to come as technologists, tech enthusiasts, as students who are going to graduate, or as interns who want to get into the field. Because we have interns here from a company that we're partnered with, and they want to learn all about tech and engineering. Ha! Bet you thought that was real. Got him. Right? So let me tell you a story. Rust is known for its steep learning curve. Who heard this? Who knows this? When we say steep learning curve, it's hard, it's difficult. So we have one here, we have half here. But in reality, it's actually not steep. In reality, Rust's learning curve isn't straightforward because it's steep. When you think you already know enough about Rust, it's going to hit you and tell you, no, you don't know. Because Rust being something that's not straightforward to learn allows you to set yourself apart. If you have never programmed in Rust, when you code in Rust, it's always gonna shout at you with errors. It's very strict. To have someone who's always shouting at you, telling you you're wrong, right? You feel as though you're really good, you're an expert, you're a pro, and then suddenly you're wrong. So for Rust users, could you tell me, raise your hand if you know what this is? It's an enum. And you can notice that in Rust, in our enum in Rust, it says, everybody count? 1, 2, 3. And yet, at the bottom, Rust is complaining, as you can see, the red line here. Wendell said, hindi niya cover lahat. He didn't cover everything. He only covered what? 1, 2. You're not exhaustive. And this is Rust. It's going to complain at you if you're wrong. No matter how good you feel, no matter how dog you feel, it's going to say, you're wrong, brother. Fix that. Okay? And this is an example. He's going to say, missing match arm. 3 not covered. And this is the baseline of Rust. It's going to complain. So even if you're coding in JS, there's this faint aura of Rust talking to me. He said, oh, I'm coding in JS, if, else, if. I need to be exhaustive. Right? Because Rust taught me I need to be exhaustive. So it carried over to JavaScript. I wasn't using Rust, I was using JavaScript. And yet, the way Rust taught me how to think enabled me to think better. Take this, for example. It says here, send sync arc mutex box .e. Wow, so intimidating. But if we summarize this, it simply means thread safety. When we say thread safety, it means you should allow it to be used in multiple contexts. Meaning, kung marami kayong tumatakbo na executions, kailangan dumana siya sa lahat nang walang conflict. That is thread safety. Now, I was programming in JS ulit. And then at the back of my mind, I was working with async functions in Rust. Who knows async functions in JavaScript? Async functions in JavaScript. Raise your hand. Right? And then I was thinking to myself, I have to be safe. Once again, Rust carried over to JavaScript. So what's my point? My point is simple. Rust teaches you how to think about your code. Everybody say, think. One more time? Think. it's so strict that it elevates you to a higher level of consciousness. Meaning, when you're coding, you're not just mindless. Because your experience with Rust allowed you that, oh, I need to be exhaustive. And that's why for half a decade now, I have been programming in Rust exclusively. So today, I'm going to share to you guys what opportunities exist for Rust in blockchain technology and what do I do exactly. I want to give you guys simple examples you can understand. And another assumption I'm going to give you is that I'm speaking in English majority of the time because we are sponsored by Ross Foundation. So from time to time, magtatagalog tayo. But for the most part, I'll use English. That understood? Good? Okay. So Rust for blockchain. There are 4 things that I usually work on when I do Rust for blockchain. So let's start with CLI. For example, recently I created a CLI tool that allows you to create games on chain, on the blockchain. And the crate or the package that I use is ClampRS. Everybody say ClampRS. ClampRS. Who knows ClampRS? Yeah, we know it. Okay. So another thing is Backend. Everybody say Backend. Backend. For example, recently I needed to create a backend that allows you to play keys. Simple stuff. You guys can do this. And I use Axum RS. Alright? So recap, what's the 2 use cases we can or work that we can do with Rust? What's the first one? CLI. What's the second one? Backend. So are you starting to feel that you can do something with Rust? So if you know backend, let's say you do backend in JS. Heck, if you do backend in Python, you can do backend in Rust. It only takes what? Starts with the letter P, practice. That's it. If you can do backend APIs in any language, you can do it in Rust. So third use case, smart contracts. I assume this is something you're curious about because I've heard you want to know about crypto and Rust and how it relates to blockchain technology. And I'm happy to tell you that you can use Rust to build smart contracts. Smart contracts is just a fancy way of saying a program that is not deployed on a server, but deployed on a blockchain. Pag sinabi mo smart contracts, program lang yan na hindi mo dineploy sa web server. Dineploy mo sa blockchain. Alright? So that's the only difference. Still a programming language, still logic. This time you just deploy it on a blockchain. Alright? Everybody say blockchain. Blockchain. And this is what I mainly worked on before. I started working on protocols and networks. I used to work with smart contracts heavily. And when it comes to smart contracts, kasi, are you familiar with servers? Generally, are you familiar with servers? Servers cost a lot. But in crypto, it costs more.
But when you interact with your, let's say, smart contract, you use crypto as a gas fee. So you spend money. So the risk is higher. The last thing that you can work on, if let's say, for example, you don't like CLIs, you don't like backend, you don't like smart contracts in blockchain, right? You can also do blockchains themselves and protocols. Ito yung networks na mismo. Yung mismong blockchain, gagawin nyo na siya. Hindi lang yung program na ide-deploy nyo, but yung mismong network na. So, give me a name of a blockchain network. If you can give me a name of one, we will give you a Rust Archipelago limited edition merch. Right now. So, who can name one? You guys are the Siege. Sige, let's do 2. So, Polygon Network, please give Siege a shirt. Siege, please get your shirt later. Isa pa, dito naman. What's your name? Rob, okay. What network? Ethereum. Okay, so may t-shirt ka rin. So, Polygon and then Ethereum. Right? When you do protocol and blockchain, you build those. You don't just build the smart contracts. Yun na mismo bibuild mo. So kung gumawa ka ng blockchain, pinangalan mo hotdog chain, pwede kasi marunong ka na eh. Right? And this is an example of a node that I recently built. Specifically, a node, isipin nyo ang blockchain network, ano yun eh, parang nagmi-meeting kayo, right? Nagmi-meeting kayo para mag-agree kayo. And bawat isang device sa network na to, ang pangalan dyan, node. So you call this a node. And in a network, there's multiple nodes interacting with each other because they have to talk. They have to have a meeting. Now, everybody say, exciting part. So tapos na tayo dun sa part where you guys know what jobs and opportunities you can pursue, especially you guys, because I know you're getting into the industry, you're starting to train yourself as interns. Now let's go to the hard part. Everybody say, hard part. This is hard because I'm gonna go deep into Rust. Like painfully deep. Okay? So steal your hearts, steal your souls. Let's get it. Let's build a node in Rust. How do you think about going when you're building a Rust node purely? Right? Typically, people default to an SDK called Polkadot SDK. So Polkadot SDK, para siyang framework to build a blockchain. Right? It helps you a lot. But it's too overkill for a use case. Today, we're just gonna create without a framework and purely in Rust. Specifically, we're gonna create an L2 or a rollup sequencer node. You don't have to understand that. Just know that it's a node. Okay? Everybody, just say node. Okay? And typically, a rollup sequencer node is just one. So isa lang siya. All right? So we're not gonna use frameworks because it's overkill. You only need one node.
The structure of a node is, isipin nyo para siyang app. Think of it as an app with different layers. Give me a layer of a web app. Right? It's usually two things. Give me one layer for a web app. I want on this side naman. On this side, give me a layer for a web app. It's usually The left side, go. Front end. Right? What's the other layer? Any guesses? Back end. Wow! Oh, we learned something new, right? Front end, back end. So in nodes, it's not different. It's not different. You have layers, but the difference is you have big, massive, hard layers because they do more than what front end and back end would usually do. And it's way more complicated because the size of the app you need to build is really. Okay, so it can be just one layer if you want that. Is it even a layer if it's just one? You can do 2, 3, 4. You can do 100 layers if you want, as many as you want. As long as they are different layers. Different layers of behavior. So for example, in apps, we say front end, it's usually what? Any guesses from this side? What's your name? Rain, guess. User interface. So that layer in Web 2 or in a web app is responsible for your user interface. How about the backend? What is it responsible for? In this side again. Processing APIs. Pag sinabi nating APIs, ano siya usually? What does API mean?
Serves data back and forth.
So, you process data somewhere in the world. Let's just put it like that. Okay? So those are two different behaviors. One is for UI, one is for processing data. So we have two layers, usually, for web apps. Let's take a node. How many layers would we usually have for a node? Typically, for a sequencer node or a rollup node, okay, we have 4 layers. And this is the simple version. There are more layers than this, but I'll give you the simplified version because I don't want to blow your heads for today. I want you to go home alive, okay? Everybody, it's okay? Okay. So usually there's a runner. There's something you need to call so that the node runs. Typically, it's done via a CLI architecture. And then there's routing. Usually, you need to talk to the node, and it can be done in different ways. What are the common ways to talk to a backend? Starts with the letter R, rhymes with sleep. Anyone from this side again? Rest. Right? Rest. Isa pa, what else? What other ways can we talk to a backend? Starts with a W. I already hear it. Come on, say it. WebSockets, right? So we have a runner, we can run the node, we have routing, we can send data inside, we can send data outside, or you can send data internally, you can route data internally. Now we have what? Sequencing. What do we usually send to a blockchain node? Any ideas? What data? Starts with the letter T. Allen? Timestamp? Anyone? Starts with the letter T. Transaction. Wow. Oh my God. I love that. Ang lakas lang dito. Like I've heard people say transactions. So we send transactions to a blockchain node. In a rollup, the layer that receives that is what layer? Any guesses? The routing layer, of course. Right? Because you need to send the data first to the node before you go to the sequencing. Okay? So, you send data to the routing layer sends it to the sequencing layer, and then the sequencing layer orders your transaction. Right? So, I'll send you a transaction, and then I'll order it. That's why it's called, everybody, 1, 2, 3. What's that? I can hear you. Beautiful. Okay? Now, of course, typically in a web app, we need what? Starts with the letter D. A database. So for a node, it makes sense to also have a storage layer. So you see, these concepts are very basic. It seems like they're hard, but you guys already know what they are. So the point that I'm making here in this slide is that they may sound intimidating. Wow, you have a sequencing layer. Sounds so beautiful. I sound like a text expert. Beautiful. But you already know the concepts. It's just the data at my app sequencing. So the point is, every single one of you are equally capable of using Rust to build any of the 4 use cases I gave you. And all you need to do is start. And I'm reassuring you that there is room for every single one of you in Rust. Okay? So I hope it's making sense now, okay? So now, I want to show you, yun, may laser. Can you guys see the laser? Wow, so visible. So I'll just point, right? This is an example specs of one of our nodes. For context, look at the memory size, guys. It's 1,952 watts. Because the requirement of a node is so big. So this gives you a perspective on how big a node is and how much work there is. So laki. Very big, very huge. So typically, when you start building a web app, you start designing a web app, what do you usually reflect on? Starts with the letter T. It's very hard. You wouldn't know it. It's not visible anywhere. It starts with the letter T. Everybody? Trade-offs. Because when you build a system, you want to understand what's my problem and what trade-offs do I need to take on such that I solve my problem. For example, right? You have a piece that is a letter C. Can you fit a square in this piece? Yes or no? Can you fit a square perfectly? No, because it's a curve, right? You need something curved. So you need to design in such a way that it's also a curve, so that your solution match your problem. Else you're not solving anything. So you need to start thinking trade-offs. Okay, so when you design a node, you need to start thinking, okay, how big is my node? What type of data do I receive? How fast do I want it to be? How many nodes should I spin up and deploy? Okay? Today, I'm going to give you two concepts, and I'm going to go at them quick because we only have 5 minutes. Can I extend for 5 more? Is it okay? So let's do 10. Okay? Okay. So I'm going to ask for 5 more because I want to take this a bit slow. Monomorphic versus polymorphic. It's a concept in Rust where you decide if you want your code to be statically dispatched, meaning do you want all data types to be known at compile time? Compile time is the time you compile. Hiya. Okay? Or do you want it to be dynamically dispatched? When we say dynamically dispatched, polymorphic, multiple forms, you don't know the types at compile time, but you know it when you run it, which is called runtime. Okay? So these are very important topics that I'm going to give to you guys. And the last, I want to compare two architectural decisions when you're building a node. The first one is that fat, juicy arcs. Everybody say, fat, juicy arcs. One more time. Fat, juicy arcs. Versus snacky, snacky arcs. So the difference is a fat and juicy arc is big. A snacky, snacky arc is snacky, snacky. Very small. So monomorphism versus polymorphism, also known as static dispatch versus dynamic dispatch. If you don't get it now, don't worry, you're not gonna get it too in the other slides. No, just kidding. You will. You will. Imagine you have an animal with 3 forms. A cat, dog, bird. Everybody say cat, dog, bird. How does a cat speak? How does a dog speak? How does a bird speak? Magugulat ako pag narinig ko dyan a bird, bark, 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 okay? So that means all these 3 have different ways of speaking. Meaning their types are different because they have different behaviors. Okay? So let's say we have a trait. A trait in Rust is, let's just put it as behavior. If you have a trait, you want to attach behavior to something. Right? So if you want to attach a speaking behavior to something, you use a trait named speak. And let's approach this monomorphically, monomorphism. If you do monomorphism, it means you want all data types to be known at compile time. Meaning, ahead of time, you already define all of it ahead. Simple as that. All right? So, this means if we want to define 3 different behaviors or types of an animal, we need to define each for cat, dog, bird because they are different animals with different behaviors. And that is monomorphism. Ahead of time, we've already defined everything ahead. Ahead, ahead, ahead. Ahead, shoulders, knees and toes, okay? So your types must be known at compile time. And that's called static dispatch. Wow! Ganda, like, pogi no term. Static dispatch. So you go into an interview. Yes, I know how to do static dispatch, dynamic dispatch. I know how to do monomorphism. And then, yun pala, it's just knowing your types ahead. Monomorphism, right? Static dispatch. Cool. Next is polymorphism. Any guesses what polymorphism is? Thought so. Okay? instead of defining everything ahead, like kanina, right? We implement the behaviors for each type, but look at this. Compare this with the previous slide. We have to define each one, cat, dog, bird. But for this one, we only defined one list of pets for multiple types. Okay, and then the type is box, dine, speak. What you're saying here in this part is that you want something that has a speaking behavior, but you don't know what it is exactly. Is it a cat, a dog, a bird? But the only thing you know at compile time is that it speaks. Polymorphism. Right? So types are determined at runtime. Dynamic dispatch. Woo! Beautiful. And then if you do Rust, usually if you call dynamic dispatch, you see this word dyn. If you see that, let's say you're in an interview and then you see dyn, you said dynamic dispatch, right? That is dynamic dispatch. Okay? So, when we're building a node, these are the benefits based on Grok 3. These are the benefits of monomorphism or static dispatch versus polymorphism, dynamic dispatch. Let's go over each one. Runtime overhead, meaning this is the overhead or cost that you take on when you run it. For static dispatch, we have none. For polymorphic dispatch, we have something called vtable lookup. For binary size monomorphism, it's what? It starts with the letter L, larger. Why do you think that is? Any guesses? Why is it larger? You explicitly said cat, dog, bird. So it's bigger because from compile time, you already know cat, dog, bird. Polymorphism, it's smaller because you don't have to define it ahead. You can just say it speaks, but you don't know if it's a cat, dog, bird. Okay? Compile time, it's potentially longer once again because it's larger, because you repeat. For dynamic dispatch, it's faster in compile time because you don't have to repeat your code. Optimization potential for static dispatch, high. For dynamic dispatch, is limited. Okay, so what's the point here? We're building a node, right? It's decision time. This is the time we finally finalize our design, all right? Our design for our code. Based on these specs, these trade-offs, which would you use if you're building a node? Static dispatch, monomorphism, or dynamic dispatch, polymorphism? He said if you have a finite set, meaning a limited set of data types, it's good to use static dispatch. And I agree with that. Now, in blockchain, it's very important to be what we call deterministic, meaning as much as possible, we need to know everything ahead of time because we're using money. We're losing money if you make mistakes. So naturally, we want to use static dispatch because it's faster when it's running. Oh, sure, the binary is larger, but we have, remember, how many gigs did we have in the specs a while ago? Really large. We have space for it. Compile time, sure, we can wait for the compile. It's not like we care about it. We can wait. We can compile it for a long time. And then optimization potential is high because you want to, for example, you send the money to your friend abroad. You want it to be as fast as possible, right? So the answer is static dispatch. When you're building a node, when I built a node, I opted for static dispatch for these reasons. So visualize static dispatch is this. What do you notice?
Fix. Fix po yung pagkakagawa po sa kanya.
So it's fixed. And the binary is larger because you repeated cat twice. But in dynamic dispatch, look at this. We needed to speak cat here, but we only pointed to this data called vtable. So we point to cat. The second time we point to dog. The second time we point to cut again. And what does this mean? You didn't have to repeat it. So it's smaller. Okay, so that's it. Everyone, this is my LinkedIn. I know we weren't able to go through the entire slides, but you can follow me on LinkedIn, send me a message, ask me about career questions, ask me about Rust. I'm all for it because I want to support every single one of you. With what language? Any guesses? What's that? Rust. So thank you once again. My name is Christian, and this is Rust for Blockchain and Rust Archipelago.